So here I have a summary of the ambiguous case of the law of sines. If angle A, side B, and side A are given, that was the situation I showed in the last video, then if A is an acute angle, you have this set of conditions. You have the potential for no triangle if the side A is too short to hit all the way down to side B. Side C, sorry. If A and the height are the same, then you get one triangle and it's a right triangle. If A is greater than B, then you get one triangle that exists. Okay, that's where you have the potential for, you have side A, this is B. If A is longer than B, this side here, then it can't swing by and get a second triangle. You're only going to have one triangle possible. And here, if A is between the height and B, then there are two triangles that exist, and that's the one where you have here's your height H, and so side A would come down to an obtuse angle, or I'm sorry, an acute angle or an obtuse angle, depending upon the scenario. You swing it both ways and get two different triangles. So that's this one here. So you have four scenarios basically that could occur. Then here, when A is obtuse, and we went through the idea there, if A is obtuse, not acute, so you have this situation, then if side A, which would be this other side up here, if side A is less than side B, you get no triangle because it can't reach all the way down to side C. And if A is greater than B, then you get one triangle, and it does reach down, and you can get that to work out. Now, on my last video, I did have a mistake. I had the inequality wrong here when I wrote it out, so just be aware of that. It should be if A is greater than B, I almost said it wrong, then there's one triangle that exists. Now, the big difficulty comes in is if you don't have A, B, and A given. If you have three different pieces of information given, you've got to be able to sort of convert everything. So for instance, if I were to give you, let's say, big C is, let's go with, I don't know, 57 degrees, and little a is 32.5 feet, and little c, let's throw a little c in there, as, let's see, I gotta make this up, and it's gotta be good. Let's make it 41.3 feet. There we go. So now the question is, what do I do with this information, because it's different than what we have here? So is it A, is it B, is it H? What compares to what? I guess the best thing to do is to think about the original triangle that I displayed, having side, or angle A, this is C, and B is down here somewhere. And then you have side B and side A and side C. So in this triangle, or potential triangle, we talk about the three given pieces of information are angle A, side B, and side A, right? So if I give you C, A, and C, then you can set up the triangle in a similar way. You just got to switch things around. So what I have now is a 57-degree angle, that's C. So the given angle, I always put it on the bottom left, just the visual of that is easier to work with. Side C is the opposite, right? That's going to be the one up here somewhere. So that's 41.3. Side A is the other side that's given, so that's got to be this one on the left here. Okay. So with that, then I just make all the substitutions. So So this A, the original A is now C, the original little a is now little c, and the original little b is now little a. So, okay, now I gotta come over here and make my replacements. So little a becomes little c. So this really is gonna be little c, little c, little c, little c, little c, little c. I don't have to worry about this because my angle that's given is acute, so I don't have to really worry about the obtuse situation anyway. Then I have little b becomes little a. So right here's an A, right here's an A. Guess that's it. And then angle A becomes angle C. Well, okay, so it just changes this guy right here, right? That's C is acute instead of C is, or A is acute. So I just make those changes and then I can operate from there. That is if you really care to work with the inequalities. What you could do is just use the visual, right? You could just go off the visual and say, well, as long as the side opposite is longer than the side adjacent to C, you're going to get one triangle, right? 41 feet is longer than 32 feet. So if you put that side down, if you were to swing it the other way, you're going to go past the triangle. You're going to go outside the triangle. That doesn't work. So there's only one possible triangle. Okay, only one possible triangle. So I don't have to really worry about these other conditions. Now what I have, C greater than A, is right here. It's this one, it's this condition. All right, C is greater than or equal to A. And so then I can just find that triangle, right? I don't have to worry about all the other things going on. I just find that the size of that triangle and the other information. So I use the law of sines. This is going to be A over here because it's opposite A. So this must be B and this must be B. There we are. So now I just set up my law of sines. I've got to use the C's because I know them both. So I have little c over the sine of C equals, now let's use A and A because I know one of them. So it'll be little a over the sine of A. Then I just plug in what I need. So I have 41.3 over the sine of 57 equals 32.5 over the sine of A. I don't know A yet, right? So now I cross multiply and solve for A. So I have 41.3 sine A equals 32.5 sine of 57. Divide out the 41.3. And then I know that the sine of A is going to be this fraction. Actually, I could just solve for A right away and use the inverse sine. I think that's probably the best way to go. So let's say that A is going to be the inverse sine of that fraction, 32.5 sine 57 all over 41.3. So I type that in my calculator, and remember, you're either going to get a first or fourth quadrant angle, but because I know this is going to be an acute angle, I just need the first quadrant. I don't need the fourth. I don't need to worry about trying to get it into the second for an obtuse angle. All I need is the first quadrant angle. So whatever comes out of this thing. So I do inverse sine 32.5 times the sine of 57 divided by 41.3, close parenthesis, and that is approximately 41.3 degrees. Okay, approximately 41.3. All right, so that's my value for A. That's one of my answers. Now, knowing that answer, I can also find a value for B by subtracting from 180. Right, so angle B is going to be 180 minus our 57, which is 180 minus 57 is 123. Is that right? Yeah. So it'll be 123 minus 41.3. That'd be 81.7. I think. Let's double check. Make sure. 180 minus 57 minus 41.3. 81.7. There it is. So that's my angle B. And then finally, side B is found again using law of sines. I'm going to go back to the C's because that's the given information, less rounding involved. I'm going to go over here. So it's going to be this formula, but with the B's on the other side. So I'm going to have 41.3 over sine of 57 equals small b over the sine of big B, which is 81.7. Solve for B, I just multiply both sides by the sine of 81.7. And so B is going to be, I'm going to skip a couple steps there, just 41.3 times the sine of 81.7 all over the sine of 57. And of course, if I punch that in the calculator, round it off, 41.3 sine 81.7 divided by the sine of 57. Get 48.7. So that one is in feet because it's a side length, 48.7 feet. Okay. So again, if your sides are different than the three given, or your sides and your angles, if they don't quite match up with the A's and the B nicely, you can still position things in the way that we need, in this in the triangle with the bottom left angle, the opposite side, and then the adjacent side here. You can still set them up that way. You just have to sort of reconfigure what letters go where over here. And if that's not clear to you, then I would just suggest drawing a diagram out and then using this opposite side across from the angle that's given and just compare it. If it's bigger than the adjacent side that's given, then there's only one triangle. If it's smaller than that one, then you'd have to figure out, based upon the perpendicular height, whether or not there's two triangles, one triangle, or zero triangles, okay? Like we did in the last video.